Alright, this is lesson 5.1. These are the guided practice questions. I'll be talking through some of the vocabulary as we do these problems. Alright, so 3m plus 4p. To review, that 3 and that 4, those numbers are attached to a variable. Remember, variables being the letters. The number attached with a multiplication. Those are called coefficients. So 3 is a coefficient of m, 4 is a coefficient of p. This whole thing is what we call an algebraic expression. There's no equal sign, so it's not an algebraic equation. It's an algebraic expression. It has letters, which makes it algebraic. It has an operation of addition. It also has two operations of multiplication. So to do this problem, you're going to substitute for m and p, because at this point we know that m equals 2. So I'm going to substitute. I'm not going to write just a 2 because that makes it look like a 32. It's a 3 right next to a 2. Plus a 4 right next to a p. And now I'm going to use order of operations to solve that. So I would try to do the parentheses, can't do anything inside of them. Exponents, I don't have any. Multiplication, 3 times 2 is 6. 4 times negative 4 is negative 16. Now I'm ready to add. They have different signs, so I subtract. Sign of the larger is negative. So my answer is negative 10. To review, if you have a little 2 up and to the right, that's called an exponent. That is n squared plus 5. That represents n times n plus 5. Once again, algebraic equation. There is a coefficient here. You can't see it. If there is no coefficient, then it's an understood 1. I'm going to write in there just so you remember you do have one of these n squareds. So I would do it in order of operation. I'm going to go ahead and substitute the 6 for n. So my problem is now 6 squared plus 5. That'd be 36 plus 5, and your answer is 41. Alright, so let's go to the next one. Once again, you may say, well, I don't see any operation here, but there is an operation because it's a coefficient of 6. That's 6 times p times p times p, or p to the third, or p cubed is another way of saying that. So once again, substitute. P in this case is negative 4 to the third power. A negative times a negative times a negative, well, that's 3 negatives. That's an odd number of negatives, so you have a negative. So negative 64 times 6 is negative 384. Pretty easy problem. Number 4. Number 4 says a website charges 99 cents to download a game and $12.49 membership fee. Write an expression that gives the total cost of dollars to download G games. In other words, we're not sure how many games we're going to be buying, but here's what I would look at that. It costs 99 cents for every game, so that's 0.99 G. I'm using 0.99 as a coefficient for the number of games. 99 cents for every game is another way of looking at that. And I have to pay $12.49 for a membership fee. That $12.49 we'll learn is called a constant. It does not change, but this is a coefficient variable, and that is an expression that then will solve for that. If I want to solve for, how many games does it say? 6 games. I would put in 0.996 for the number of games plus 12.49. I'm going to be multiplying this, which would end up being $5.94 plus $12.49. Add those together and you get $18.43. And the last one, you're supposed to determine whether x minus 3 and y minus 3 have the same value, and whether that's sometimes, always, or never. Well, if I don't know the x and y, I can just choose an x and y. I could choose like x equals 7 and y equals 2. So 7 minus 3 is 4. Y, well, 2 minus 3 is negative 1. So not always, at least. So I know it's not always. Could it sometimes work? What if I would have said x equals 7 and y equals 7? 7 minus 3 is 4. 7 minus 3 is 4. Now it works. So the answer is sometimes. Can't be never, because it just worked one time. So when will it work? When x is equal to y.